Hello guys, welcome to my channel. I'll try to speak louder. Okay, we got a HD7970 3 gigabyte memory, which basically doesn't work. I'm not sure if fans pin, but I will let you know. I will put it in description. So let's just start with this. You can find this on other channels, but I will do it real fast because I really want to do just fast video. So we got here, no, let's start here. So we got 12 volt PCI Express here. It's going up. It's not short. This one is ground. It's gonna be short. And then you got this is most likely ground, 3.3 volts. Yeah, and this is not short. This is actually quite low. 3.3 volts here is like 240 or something like that. I'm sure it's here. Yeah, it shows 100 here. Yeah, it's 100 because it's plugged in the board. So normally 3.3 will be like 240, I guess. Yeah, it's here as well, 3.3 volts. But because now it's plugged in the board, but there is no short. That's what we want to see. Got plus 12 volts here. It's no short. And this is 8 pins, so no short, plus 12 volts. You can see. Yeah, so now we got a memory. This one is ground, 60 ohm. What is interesting, if I use 200 ohm range, it's 40, but it's absolutely fine. And this one is Vcore. Got about 2.7. You see, we got fairly good wire. It's not a big difference. Yeah. Now here we have, what is this? I have no clue what is this. 16 ohms, but there is about 1.9 volts. It's probably a display part. This one should be 1.8. We're not gonna have that one. We have 180 ohm or something like that. But it really depends on your multimeter, so it can be different anyway. So it's not really worth it. We just need to have a range which is proper. Okay, so let's turn it on. Resistance is okay, so we can turn it on. And now we got it on. We're changing to voltmeter, and yeah, just fast check. We should have 12 volts all around here. All these capacitors should be 12 volt. So basically this should be 12 volts. So we got all there. I check it before. I check resistance. These resistors 0 ohm, 0, 1, 0 sensing resistor. We got 12 volt everywhere. So we got also 12 volt from PCI Express here. Yeah, we should have 3.3 here. Yeah, we got it. And now here we got 3.3 volts, and that's all what we have. So we got 3.3, we got 5 volts here. I think that 5 volts is needed for the HDMI. Yeah, we got 5 volts there. Yeah, so first voltage, if everything is okay, will be 1.8 volts, which GPU basically needs to communicate with PCI Express and with BIOS and all this stuff around. So it should be here on this coil, right? We got 0.28. So we got step down converter here. See it? I have no clue what is it. But I went through the pin, the middle pin is output on both sides, and then you got 2 pins out, 2 pins out. You got basically you got capacitor attached. That's probably producing the frequency with that resistor. But what you have underneath your capacitor, which is input. This capacitor is input, and we got load there. So what I did, trace that. Basically it's going from this end, and it's 0, and we've got a ground here, which is 0, and we got a plus 3 volts. So we got plus 3 volts, and I also check we've got a 3 volts from PCI Express. So that's the first thing which you need to check. You need 3 volts here from PCI Express slot. Can't get there. This middle pin. This middle pin will be 3 volts. You see? So left pin is ground, the right pin is output. It's connected. There is a 0 ohm resistor. It's connected. It's connected to this capacitor underneath this chip. I checked. Basically, this is reference board, so you're gonna have it on many motherboards. But I check the same circuit is on this one, which is Club 3D, the same card. Okay, so from here we don't have this pin, which is output, and it's because this is AND, basically logic AND, and this pin all the way underneath on the left here is 0, 0, so we don't get power good signal. And basically power good signal is divided from basically you got a 3.3 volts here, because it's a logical AND, so you got 3.3 VCC. So that way you get like power good from 3.3 volts, but you need a power good from these two connectors, and they got the sense pins which are grounded, these middle pins, and this middle pin in 6-pin connector. Sometimes you need it in 8-pin as well, sometimes not, but this one as well, which is sense additional for 8-pin connector. So basically this power good signal is divided from these two connectors, and I got this card here just to show you. See all these transistors around? Those transistors basically sensing 12 volts. There are some voltage, divider resistors, and then divide is 12 volts. So you should have something about 12 volts in order to get power good signal, and then you should have this basically grounded middle pin. This, if you don't have them, the car will not turn on because it's missing basically these connectors. So basically all this bunch of transistors, so basically that power good signal coming from here, basically coming here from here. So again, if you are missing 1.8 volt, you won't have any other voltages, and most likely you will have a fail here, because this transistor and resistor basically creating power good signal. If you have power good signal, you have 1.8 volt, you're missing other voltages 1 volt, I don't know, core voltages, memory voltages. There are resistors here which are providing power good signal for those other circuits. So if you're missing other voltages, you should go for other transistors here and resistors and check them if they are providing power good signal before you're gonna remove these ICs which are more difficult to remove. Okay, so I'm just quickly going to provide some resistance of this board. Basically, I'm not gonna check these like 12 volts. So, just to, because I know this card is good, so I'm not really interested that much. Yeah, I can do it fast, like 12 volts. It's not short. This one is 3.3 volts, not short. Yeah, it's 3.3 volts is usually like 240 ohms, but it really depends, because your multimeter can, it measure with different voltages, so it can be different. It's not that important, but it's quite low, 258 ohms. Yeah, there is the minus. Yeah, so these are plus. You see, they're growing. So it's another plus. Yeah, what is important, basically, this memory, these are all the type memory, MFR. Not really sure what does it mean. You can see in the laptops the MFR are basically old. They were assembled usually in Korea. The new IFR are assembled in the China, only in the China. Yeah, so this is the ground, memory ground, and you see memory are really low, like MFR 6.6 ohm. Yeah, but it can be different with your and core voltage 3.7 ohm, so you can subtract 0.6, so it's about 3.2, let's say, but it's gonna be different, somewhere in that range. I don't know, I can't really reach other. Yeah, I can reach this. 21 ohm on this coil. This is giving like 0.9 volts. I think it's for display. And yeah, that's it. Core volt, memory voltages. So here we have an MSI board, which is basically reference board. This one has got AFR memory chips. Should be newer. Definitely this MFI running hotter, but car doesn't have this metal cooler. So this display here is was it 22 there? Let's see, MSI. Okay, I need ground. So this reference has 15. That one was 22. This one has 15. 3.3 volts. 168 on this range. But on this range, yeah, 253. That's why I like this. Sometimes you get automatic range. That's horrible. Can't even. Sometimes just fluctuating. So here is a 1.8 volts. Got 286 ohm. and I don't know if this is interesting. I'm not gonna do that at the moment, but here we have a memory, and that's 61 ohm, but it's gonna be less here, 61 ohm on that range. It's like, yeah, there's so many capacitors, they will charge long, so I'm not sure where we will finish. Yeah, somewhere here, 43. And now yeah, 0.2 is ground, and this is a Vcore 3.1, so it's like 2.9. Yeah, and that's it. Was 1.8, 286, 3.3 was 250 or something like that, and then this display rail was 15 ohms. So this is MSI card. So these are the resistance you can expect, but it really depends. You got a ICL 7000 or 7106 measuring equipment. They should really show very similar, but yeah, it's just to be sure you don't really have something really strange, and you got something really strange, then you can search around. Okay, so and here's the fixed MSI. Basically you can see the stress test is absolutely fine working, and basically there was only missing power good signal. So yeah, I'm going to make some pictures and I will show you some pictures, and I don't know if you are interested. I don't know this if it's gonna be visible. These regulators, maybe not. Maybe you can read it. Maybe you can. I'm not sure. This circuit under this plate, it's got a name chill on it. I'm not sure about this one. This one, but this one looks different. These MOSFETs are all metal. These are plastic, but there is more of them. So this card, this MSI is actually a well-built card. Speaking about this cooler, this is aluminium. There is really no plastic. This is rather like toy. It's got plastic, but yeah, it's bigger. It's running colder. These fins are smaller, but they are soldered. So yeah, but this card is running 70 degree, and this card is running 65. And also this card is rather a little bit noisier. It's got surface mounted coils, and these ones got, these are soldered through the hole. So these coils are different, and this seems to be more quiet. So if you can choose, this card will be colder, but memory will be running hotter. So I don't know. And yeah, you can't run maths on AMD cards, so if you So we have a second part of repair. here. Yeah, so first part was a missing resistor from the sense signal from PCI Express 8 pin, which was basically connected to this emitter. You can see it here if you're interested. Not now. Oh, I swap it. So this is basically 6 pin, this is 8 pin. So this is 8 pin. And there was a resistor here. 0 ohm resistor. Yeah. And yeah, these cards, they were like job lot. It looks like they were returned. They were returned from maybe customers or maybe somewhere where they built computers, and I got more of them, and some of them missing parts. So people are really not careful. They, you know, if they knock this, put it somewhere on the table, on the tweezers or whatever they got there, they can knock off these things, obviously. So, but this looks like this was like secondary things, because if it is in use, there is no basically reason to knock something off, especially the card which was used for a while. But it was used just for a short time, and I guess there was another fault, and it was intermittent booting, so that's why it was somewhere on the table. It was problematic, it was returned, and it spent way more time on the table, on the shelf, and then it's probably way hard that something is knock off. Other card I get from them, they got knock off components as well. Some of them they knock off components because they just didn't pack it well, so you can imagine how they treat those cards. Yeah, so but back to fault. So we got this card connected. I draw the schematic. Basically, you got a sense signal from the PCI Express power connector, and you got the voltage divider from 12 volts, which is turning on this resistor, and then basically they use PCI Express 3.3 volts, PCI Express 12 volt to make sure there is a voltage from the PCI Express connector, PCI Express slot, and PCI Express power connector. And the same is for other power connector, and you got these transistors. Basically they switch and they make sure you got good voltage on the power connector, but they make sure you got good voltage on PCI Express slot. So basically that signals coming, sense is turning on this first transistor, and then you have to have a 12 volt from PCI Express. It's basically turning on this transistor, and if this one is on, this one is off, you got power good signal here, positive, power good. So this one is for 8 pin, this one is for 6 pin. So we measured both of them, and basically this one is okay. It's got short here, so this one is closed, but this one is open. So we got a problem with 6 pin. So it's got nothing to do with our secondary fault. And you can see we got this first divider here, and we got 0.9, almost 1 volt here, and that's the same on the base of transistor, you see, and we got a power sense ground. We can basically go to continuity mode. You can see, be careful, so turn it off then. So after first, yeah, normally we will have here like 0.67, 0.6, 0.7, which is voltage on the base emitter if it is on. But if you got 0.9, it's suspicious straight away. So it's it looks like this transistor is not good because 0.9 is just too much. There is not gonna be 0.9 unless you get like 500 milliamp, but it's not possible. You won't get that much from here because if you get, you won't hold it. It will burn your finger. So it looks like that transistor. Most likely that transistor. It can be this resistor, but it looks like this transistor is temperamental. It booted few times, so that transistor is probably painted properly, but it just got some imperfection on the chip, and it's just sometimes works, sometimes not. It's probably on the edge. There is a channel which is probably very thin inside. It's hard to say. So I will replace this transistor, and then we will see. I'm just going with you through this. So if this is if we got a positive voltage here and sense here, we should have this transistor open, and it should be very low here. It should be like 0.05, 0.1, a low current, you know, the transistor is saturated, but it got 0.6, as you can see. That's too high. It's no way there is a current flowing to the ground. So that's the thing. That current is basically coming from here. Here we got divider from 3.3 volts, and there we have 0.9, and we got 0.1. So this transistor got like 0.4. It means it's not open because 0.4 is not enough to open this transistor, and because it's not open, basically we got a high voltage here. If it is open, we got here on the collector voltage. If the transistor is saturated, probably 0.1, 0.2, because 0.7, which is basically done because you got a base emitter, it's basically lowering this voltage from 12 volts 0.7. So this one is open, and we got saturated voltage about 0.1 saturated transistor, so we don't have power good signal, and we don't have 0.9 volt. We don't have, as you can see, we don't have Vcore. We don't have anything because we don't have power good signal. Which was I talking about a power good signal. It's basically, here you've got a reference board. You can measure it on this resistor. This should be power good signal from this side. From other sides, I show you there was a checking point, so you can use that checking point. But from this side, this transistor is gonna have power good. This transistor, I think, has one more here. Not probably this one or this one, so it doesn't matter. So we don't have power good, and we don't have 1.8 volt, and we don't have any other voltage. So I'm gonna check. This transistor is marked W1A, which is general purpose transistor. I got some board. There is not the same transistor, but whatever transistor will do the job because this transistor is just switching. So I'm gonna use, I found 1L. This is probably higher current. This is like 1 amp. That transistor is probably 0.2 amp, like that. But it doesn't really matter. This transistor is just switching, so you don't need anything special. So I'm gonna stop the transistor. We'll see. Now I'm gonna turn off this, turn on, just to see. Maybe it will boot this time. And you see it's not booting. Sometimes when I measure, touching the things around is like probably creating some field, and it's running. So yeah, I'll remove the transistor. I will be back. Okay, So we got another transistor there. As I said, it's got 1L marking on it, and we got a screen attached as well, so maybe you can't see, but I can see. We got a screen, and we're gonna trace this. So basically plus 12 volt is coming, you can see it here, first divider here, plus 12, and on the base, see, now we got 0.67, you see, now we got 10 millivolts basically here, shorted. So basically it's this base on this transistor 0.69. So basically 0.69 here, 0, almost 0 here. You see, if here we got 0.67, so that's the only different. And therefore in the collector you see you got 0.07, 70 milliamps. So basically this base is not active, 0.07 against the ground. It's doing nothing with transistor, it's not gonna open the transistor, and we got our power good signal here. It's connected to this transistor as well. This set of transistors is doing the same. They got just swap 3.3 and 12 to just make sure that all voltages are present to give you power good signal. And yeah, we got a screen, so obviously you're gonna have core voltage 0.94. One important thing is when you measure like this, you see I got the fans from the bottom, so I unplugged the fans just to avoid the damage. At 1.5 you see this is 1.97, I think that's some display rail or something like that. And somewhere here should be 1.8, not 1.8. Yeah, you see these capacitors got 1.8. Yeah, it's getting a little bit hot. See, this is 0. Yeah, this is a display rail, I guess. You can have 1.8 somewhere else as well. The BIOS chip 3.3. So all the graphics card, maybe because AMD as well. So BIOS chip is 3.3. It's easy to, basically you can use this CH349 programmer. You can read straight away the BIOS. If you're concerned, maybe it is BIOS. You just let me see some more voltages here. In the future, maybe if we have that card, we can check all these voltages before we will assume that the GPU is not connected properly. So the 1. Yeah, these are memory 1.5. It's always wondering about these resistors. The voltages are on these resistors, 1 volt. And these two are connected, I guess. Yeah, 1.02, 1.02, 1.5. 90 milliamps. 1.5, maybe I can do it this way. This should be ground. And then both sides needs to be grounded. This capacitor 1.5, 1.5. And you get this AMD card, you can run basically mods or any software which will show you which memory is bad. But if you measure these voltages on these resistors, that can probably show you that can show you. You need to go through all of them, and then it can show you probably faulty chip. So you can try. See, you should have some 1.05 volts. It is not from power supply, and it should be 0.5. If the chip is faulty, maybe. Oh, you see, I just shorted these two resistors, and I got artifacts. You can't see them, but I can see them. So I'm turning off this thing. So I shorted two resistors. I got artifacts. Looks like I got some wrong signal from the memory, so probably card is dead now. We'll see. At least you can be more careful. Maybe I'm lucky. Maybe I damaged card. It looks good. I don't have artifacts anymore. I didn't show you, but yeah. So, but I shorted two resistors. You can see it in the video. I can't go back now. So this is 1.5, and I probably shorted somewhere here. Yeah, let's try this one. This is 1.26, 1.26, and 1.5, 1.5. No, let's see. Maybe this card. Maybe I damage it. I'm not sure which two I connected. I should go. Yeah, I should go through that video and check it again. Where was I? Probably somewhere here. So you get 1.2, 1.2, and those are maybe connected, maybe. And they both connected to 1.5. And we'll check which two I shorted. Probably these two. Both of them are 1.2. Worse will be this. This is ground probably. This is 1.5. So if I shorted those two, I'm glad to see. But yeah. Okay. So we did this pair, and this is like mirrored, so it's just for different chip. Yeah, this will be for different chip. It's both. Yeah, these both should have. Yeah, but if you got a dead card, and it can be memory problem, you can try this. You can try these voltages, which are 1 volt. So they are somehow connected to memory chip. Yeah, this one, 1.05. They are somehow connected to memory chip. So try those way, but I wanted to measure more things here. This is 3.3, I guess. It's gonna be 3.3. Just briefly measure these things for future. What is the good thing? 6.4. Interesting. 12. 6.4. 0. 0. 6.4. 6.4 and 0 on both sides. Yeah, this was 3.3. This all has sign like Q, so I'm not sure if these are transistors or drop down regulator. So here we have working card, after repair. Running stress test, decent temperature 70 degree, fan is 52, 55, somewhere in the middle. And basically this car, it was like new, like you can see these marks because it was stored. I guess this is 2013 car, maybe 2014, I'm not sure, but it was stored for years because when I disassembled it there was no even dust, it was just stored. There was the fin, these fins from inside, no dust on them, like board was completely clean. And I got more cards from the same basically supplier, and most of them, they look like they were building computers, and they had many of these cards which were returned or they damaged probably when they were working on them. So they are like new, like this one, this card. There was no dust between fins, you know, these fins from inside, there is no dust at all. Like these are literally unused card. So comparing this one, actually the heatsink looks worse, but it's probably a little bit bigger. Yeah, you got more fins there, and these bigger fans, they make it. This one MSI, like MSI is running about 70, this card is running about 65, but this one seems to me like toys. Like for example this memory, yeah, this card running 65 degree, but this memory, they are way hotter than memory on this. So this reference card, see this metal, it's heatsink for VR and memory as well. So it's way better. These memory are really cooled well. Here, yeah, the fans are blowing on the memory somehow, but this memory running way hotter. So coming further, somebody is interested, you can pause the video and you can compare, and you can find a faulty component if you want. And speaking about this, definitely it's worth it to get a microscope, or when you're repairing car, take a pictures. If you're repairing on budget like me, you don't wanna, you're not doing this for a living. You're doing this because you like electronic. So you like to literally search around, you can draw the schematic as well. Yeah, so basically take a picture. Everybody's got good quality phone now. Just enlarge a picture and have a look. Many of these cars, because they don't have that backplate shield, million components there which can be knocked off or they can be burned, so you should see it. But anyway, if you're tracing the fault like this, you don't have 1.8 volt, you got all the voltages like 12 volts, 3.3 volts from PCI Express here, and you got 12 volts here, and you don't have 1.8 volt, which basically ensure communicating with the BIOS and the computer. You have definitely, as you should see, the beginning, the fault wasn't around drop down regulator, it wasn't around the logic end. So here is way more component which can be knocked off. You don't need to even disassemble card, and you can say the first thing, these are really small. When I was younger, I used to solder them 20 years ago, but now it's pain. So yeah, but I still like to go through the board and find the fault. So yeah, I spent many hours, but I traced the power good signal, so it's good for me, it's good for the future, and I believe it can help you as well. If you don't have a voltages, it's not worth it to like soldering straight away, like replacing a drop down regulator, and it's probably better to search and to draw a little bit schematic, and yeah, it depends on your skills. But in this case, yeah, if I have a microscope and I'm the repair shop and I go through the board, I will spend 10 minutes. I will probably figure out that there is a missing component. So yeah, now there is a missing component, so nothing is burnt there. So basically this card wasn't in use for ages, like this literally new card, and yeah, I hope now it's gonna be helpful at this point when there is a shortage of chips. It will help somebody. It still performed like 1050 Ti because it was one of the top model. So what else did I want to say? Yeah, I wanted to mention this. If you like to repair these things, it's really hobby. These cars are old. You see, I repaired this car. Obviously, I'm not doing this for a living. Yeah, if you want to do something for a living, you need to have a really good source of graphics card. Like, for example, somebody who build computers and he's got returns, or like, basically you need to know, because if you want to buy cars on eBay, every second card on eBay is not as described. You don't really expect people to be fair. But there is a balance in the life, so expect 50% not as described. It means, they will say great card and a card is smashed. You can have literally like this solder, on this power connector, they are broken because the card was smashed. I don't know, probably something like heavy cooler fell on the car or something like that. It can be rusty, or if you don't have a good picture, don't expect anything perfect. So like these cards, I bought them in pair because it's easiest to repair. So I bought two cards which were the same, and they were packed together and they knock each other components. So really, people, I would say 20% of people will pack a horrible way. So and there's so much time you spend, and you have to return this because it's damaging the and also you're buying components. These big companies, they disassemble computers, they sell parts, and they are not tested. They claim they're tested, they are not tested. We will spend 3 hours replacing camera cable on the laptop, and it will be wrong, and they don't care. They will refund you. You will get a refund, but you wasted 3 hours. So don't expect if you buy from eBay, don't expect anything perfect, especially if description is card is perfect and there are not pictures. Yeah, get some social feeling, so you need to get some skills. Yeah, so don't expect to buy. Many of the cars are messed up already when you get them. Okay guys, thanks for watching, hope it helped. So here you have this Cloud 3D card, which is yeah, it's the same card, but it looks it should have different BIOS. So these ones has GPU clock 975, and yeah, so memory are running a little bit more hot, as I said. These are MFR. And the GPU temperature actually after 1 hour is the same like on MSI. What I noticed, MSI is 1050 megahertz, and it's gonna give you like 8% more performance according to this number. So basically, yeah, MSI has a better heat sink, because the fins are thicker and they are soldered. So that soldering really make a difference. But yeah, this is not about, this is more about repair. So I wanted to show you basically last thing. Here is a checkpoint 100, so you can easily measure. You don't need to risk like measure on this pin. You can easily measure in this checkpoint, on this checkpoint. So this is a power good signal. So if you're not having 1.8 volt for communication with PCI Express, go for this point if you got a reference card, because it's not on this card, card 3D. Yeah, and basically, yeah, temperatures are the same, and this card perform better. So it's better built. It's as I said, this looks like a toy, but yeah, it's not much different. 80% is not such a big difference. For example, this card is really quiet, more quiet. So it doesn't have winding coil. It looks like it has better coil, and probably those MOSFETs are better because they are not cooled very well, but according to this, actually, they're running lower temperature than MSI. This reference card is running 60, 67 and 77 degrees. So basically, because these voltage regulator modules take more space, they're probably better cooled. But yeah, temperature of the graphics card 71 degrees, about 53% of the fan. It's about the same, but this toy Club 3D has a lower performance. Yeah, so you got this checkpoint, and yeah, I will show you a picture for future reference. You can see the voltage regulator, but I have no clue their name, so I can't really help you to find a PDF or any data sheet from them.